Hello friends, today I'm going to solve LeetCode problem number 947, most stones removed with same row or column. So we are given a 2D plane, and on that plane, on any of its coordinate points, there could be any number of stones. So what we need to do is we need to remove stones from the plane such that its row or column has at least one stone not removed, and we need to return the largest possible number of stones that can be removed from the plane. So let's see an example here. This is the example given to us. I have just arranged these into a 2D plane so that it is easier for us to visualize. Now what we need to do is we need to remove any row or column, any stone such that suppose we are removing this. Suppose we are removing this stone. So in order for us to remove this stone, there should be at least one stone on in that row, and or at least one stone on that column. So here we have one stone in that same row, right? And also we have a stone in that same column, so which means that we could remove this stone. So we'll remove this stone, and now what I'll get is my new plane becomes this one, right? Now can I remove this stone from this plane? Yes, of course I can remove, because there is one stone in that column, the column which this stone shares. So I can remove either one of these two stones actually, but I'm just gonna remove this one. So I'll remove this stone from here. Now about this stone, can I remove this stone? Yes, of course, because it shares a row with this stone, right? So I'm gonna remove this stone. Now the number of stone in this coordinate point is 0. Now what about this stone? I can remove this stone as well, because it shares this column with this stone. So I'll remove this stone. The number of stone here is 0 now, and I can also remove this stone because it shares the same row with this one, right? So the total number of stones removed is 1 2 3 4 and 5. So these are the total number of stones removed. So how could we solve this problem? Basically we could solve this problem using a DFS method. So what we need to check here is we need to check first of all, we need to keep a visited list, because once we have removed the stone, we are not gonna check it, revisit that stone. So basically we have removed this stone. Then in order to remove this stone, we do not take into account that there was a stone previously here. We just see the current state of the plane. So for that we keep a visited list, visited dictionary, and then we also need to check is the index of since we are for this to remove this stone, we loop over each of the row, and we loop through each of these elements and see if there is any one which shares the same row and column which this one. If yes, then we are gonna remove that stone. So basically we are gonna increment the number of count of stone that we are removing from the plane. So let's code our solution. So what we need is we need a visited list, visited dictionary, and then we need a DFS function. So let DFS equals to function where we are gonna pass the index of the stone that we need to remove. Basically the index is the index at in this array, in the stones array. So we take the index and then we identify the row and the columns. The first 0th element is the row and the 1st element is the column. So I then identify the row equals to stones at index 0th, and column equals to stones index column. Now next what I'm gonna do is I'm gonna check, right? What I'm gonna do is now my first index, I start from this one, my row is equals to 0, my column is equals to 0. Okay, so now I'm gonna start iterating from the first one, but since I have already reached here, I'm actually marked this as visited, so I'm removing that stone, so I'm marking that stone as visited. So visited index equals true, so I mark that stone as visited. Now I start iterating from the very first, and since this one is already marked as visited, I'm not gonna visit this again. Now I go to this next index and I check, is the row or the column equal? Yes, it shares the same row, right? So then I'm gonna add it to the remove list. I'm actually gonna increment the count, and now this will be my next. I'll start the DFS with this index next. So here for let I equals to 0, I is less than stones length I plus plus, if it's not visited, I is not visited, and stones I, the value of 0, that is row equals to row, or the value of column is equals to col. If any one of these matches, then I need a counter, so can remove equals to 0, starts from 0, so I can remove, increment the counter with DFS. So I'm doing DFS and on that index and adding a 1, and then finally I'll return return can remove the total number of indices that we can remove when. So at the end what I'm gonna do is, so I start from this index, from index 0, and then I iterate, right? So this one is already visited, so I do not visit it again, so I move on to the next index, and this index I know it shares the same row, right? 0 and 0. So now I visit this this one, this row, this stone, and then for this stone, now I again iterate. So since this is visited, this one is visited, I do not visit them again. Now I come to this position, and then I see that this shares the same, this doesn't share the same row or column with this one. Yeah, no, it 0 doesn't match 0, neither one match 1, right? So this is not sharing same row or column with this one. So I move on to the next one. What about this? 0 is not equals to 0, 1 is also not equals to 1. So I move on to next one. Yes, now it's sharing the same column, right? 1 is equals to 1 here. Since 1 is equals to 1 here, so now I add this to my visited list, and then again I start iterating from the first, and this is visited, this is visited, I do not visit them again. Now is 1 and 0, is the row equal to this? No, it's not, right? What about the column? Is 0 equals to 1? No. So I move on to the next one. This also doesn't have shared same row or column, so I move on to the next one, which is the last one. This shares the same row, right? So now I visit this, and then finally, and then this becomes my new I start iterating. I visit this, and from here I start iterating to check if it has the same row or column. So I do not visit this again, not this again. This doesn't share same row or column. This one shares same column, right? So now I visit this one, and then I see that these two are already visited. So once I visit this one, I can start iterating from my loop. So these are visited, this is not visited, and I see it shares the same row here, right? These two are sharing the same row. So now I visit this one also, and then finally I start from the first, and then what I see here is each of the rows, each of the stones here is visited, right? Which means that each of them have been removed. So since they have been removed, I then return my count, and then finally return my result. So for a result here, what I need to do is let final result is total removed equals to 0, and then for I equals to 0, I is less than stone's length I plus plus, and then what I'm gonna do is I'm gonna check if it's visited, then I just continue, that is all the steps here will be skipped. If not, then I'm gonna visit that index, and then perform my DFS operation, and then finally I return my total removed. And I'm doing here a for loop because what could happen is I could have a separate, like I could have stones something like this. So I could have something like this. So actually separate, so I could have something like this here. Now here in this case, what I have next is this is index 3 comma 3, so I have one at stone at 3 and the other one at 3 4. All right, so while I am iterating through, while I start from my index 0 here, I start from my index 0, and then I will start performing my DFS operation. I visit 0, and then 0, from 0 I visit this because it says the same row and column, right? So let me just clear all of this thing and show it to you. So I visit this first, then I visit this second because it shares the same row here, and then for this one I start iterating again, and I check do any one of those share same row or column. One, yeah, this one, it shares the same column here, right? So then next I am visiting this thing, this stone, and then again I iterate and then check same row or column. So far this one is sharing same row, right? So I remove this stone next, and then I again start checking from the first again. And then I found this one, this is sharing the same column, so I remove this next, and then I start iterating from the first again, and then I check, keep on checking until I find these stones sharing the same row with this one, right? So now I remove this one, and then I start iterating from the beginning, and then all of these are already removed, so I do not remove them again, basically already visited, so I do not visit them again. And then when I check this, it's not sharing the same row or column with this one, right? This one, which is the last stone that I removed, nor this is sharing the same row and column. So what I do is I actually return my count, which was equals to actually it will be equals to 5, because this has a count of 0, it's starting from 0, so this will have a count 5. So I return my count 5. So here I return my count 5, and then next I again iterate, move on to the next value of I, and as long as it is not visited. So what I do is I started from this one, from the for loop, so I again keep iterating until I found another element which is not visited, and then I perform DFS on this one. So then I am taking the count, so this will have a count of 0, the local count of 0. So I start iterating from the first, since all of these are visited except this one, and this one shares the same row with this one. The count is equals to 1, local count is equals to 1. So the global count, I return the local count to the global count and add it to that, and my final answer is equals to 6, which should be should be the total number of stones removed, right? And let's see if we could do that. I can remove this here because I have one here. I could remove this because I have one in the same column. I can remove this because I have a one sharing the same row. I could remove this because I have the one sharing the same column. I could remove this because I have one sharing the same row, and I could not remove this because it's not sharing row or column with any other stones which has not been removed, right? So what about this? I could remove this because it's sharing a row with this one, but I could not remove this, right? So the total number removed is 1 2 3 4 5 and 6. So that's our answer here. Now let's run our code and see. Okay, all right. So many typing mistakes. What again? VSI. Let's submit this one. So talking about the time complexity, well, I am visiting my for loop every time I encounter an element with same row or column, right? So it's basically n squared. I would say it's basically n squared solution, O of n squared solution, and that space complexity is O of n.